Okay, so today we're going to take a look at part 2 of the K1 server attack. If you haven't already done so, please ensure that you fired up both Kali Linux and your target machine. As we saw last time, there is no information here. There is no login that we can take a look at. Now, you've probably cracked the passwords for John and Harold already for this system, so you could probably log in using those credentials if you really want to, but we're going to try another blind network-based attack for this system. Okay? First things we need to do is to remember exactly what we had in place, what our network settings are. For me, it's 198 on the 156 Class C network. All right? And I also need to understand what my target IP is. Now, I've done this already. I don't know if you can make out the IP address here, but it should be the same for yours. I know my target machine is 134, so I don't need to scan my whole network, but I do want to take a look at the detailed information with regard to versioning. All right, so I'm going to run the nmap scan again, checking for specific service information and version numbers for those different service vendors. Because we're doing some pretty detailed scanning, nmap is going to make us run this as root, so we do sudo nmap -s, the service and the version information. We might as well take a look at operating system information as well, although we have some indicators here what the OS is. We're running on Red Hat Linux and it's running on Apache. Now, these can of course be manipulated and faked out, but we have some intel here. And of course, our target IP address. While we let that run, I'm actually going to open up a new tab, zoom in so we can actually make out what it is I'm doing here, and get ready for the next step in our attack. Okay, so if you want, as I mentioned in our last class together, you can take a look at trying to attack an openSSH. It is an older version and there are some vulnerabilities related to it. I've never been able to get that attack to work. If you want to try, by all means, go ahead. In a real pen test, you should identify that this service is open, that there are issues with this service, even if you're not able to realize those vulnerabilities. You would certainly want that to appear in a report. We have Apache running, and of course we do because we see it right here. We could do some research around vulnerabilities, but really we're going to focus right now on the mod SSL module installed in Apache, specifically that version. So we're going to do a little bit of research specifically on that. And we could do some research on the website. One of the things you can use is Derb, or two things actually. Derb and Nikto are two website enumeration tools that you can try and take a look at and see if they give you any information. But we will be looking at those tools when we start attacking websites specifically. So we're not going to get any, you might get some benefit. I haven't run it in a while, so maybe you do. But we're not going to target just Apache. We are going to attack the mod SSL version 2.8.4, okay? Running on Apache 1.3.20. Both of these tidbits are important. The version of Apache and the version of the mod SSL module that SSL or TLS is using in this case. Alrighty? So that's what we need to do. Any questions? As I said, I've included extra notes here, and I'm going to keep referring back to my notes because I don't want to miss anything. Alrighty? The first thing we want to do is do a search exploit for that information. Now, I like having tabs so I can quickly jump back and forth and look at information. That's my workflow. I also like creating directories and doing my work inside of those directories. And I'm going to run a search exploit against mod SSL, and I'm not going to look for 2.8 2.4. That might be too specific. I'm just going to do a more general search, like 2.8. And before I hit enter, as you can see in the documentation, I really need to apologize for the names of the resulting exploits that it discovers. We live in a world of hackers, and we live in a world of immature children, by and large. So some of these things have some inappropriate names. Some of the passwords are inappropriate. This isn't as bad as some of the other ones that I've seen, obviously. Okay? And in a real world, I would try each and every one of these attacks. But as we've seen in the past, I'm going to focus our efforts down to a specific vector of attack. And that is going to be this instance of this vulnerability. But I'm going to use the 47080 source code. And as we did last time, we copied the source code over. And I said we do this to avoid messing up the original source code that's already in place. Same thing here, same thing now, especially in this case because we're going to be modifying this source code in a very little while. So as before, cp usr share exploit db exploits unix remote 478 080.c, and I want to copy it right here. So I now have this source code sitting right here. Alrighty? Oops. Wrong one. First things you should do, well, you can try doing a test compile and it's going to fail. And I'm going to show you why. Let's first take a look at this file. When we take a look at the first 10 lines, we have a block of comment that is actually pretty helpful when we take a look at it here. All right. First off, it says it requires Lib Ssl Dev, which means we need to install it. It also says when you compile it with the lcrypto switch. Okay. It talks about an object dump. We're not going to worry too much about that. And it says if required, host ptrace and replace wget target. Not really sure what that means, but the first time we run this, after we've completed it and properly configured it to run properly, you're going to see exactly what this means. And this is where we're going to get into modifying our source code. Okay. But nevertheless, it tells us we need to install Lib Ssl Dev before we do anything. And this is easy to prove because we can try and compile it, gcc-o, and I'm going to call it SSL. You can call the executable whatever you want. I'm going to call it SSL because that's what I'm targeting. All right, and then the source code is 47080.c, tab is your friend. And right away, it says you need to include the SSL headers from openssl, which makes sense what they're talking about here. So I am going to need to install Lib Ssl Dev. So you go back, apt sudo apt install Lib Ssl Dev, just like that. Lib Ssl Dev, perfect. Now it's going to ask for your password. And because it's a single package, it's not part of a package of packages, it's just going to go ahead and install that for you. Alrighty? So now, when you compile this, and also because we're now reading the instructions, it tells me to use the -lcrypto tag. It should compile without complaint. So we now have an executable called SSL, and it is, of course, because of GCC, already has the correct permissions in place. Are there any questions? Does that make sense? Leave that open. I don't even know why that's open. Are there any questions? Alrighty, let's move on. So now that we have our executable here, we could go through the source code and try and understand what arguments it expects, but the easiest way to do it is just to simply go //ssl and execute it. And this is quite a list of expected arguments. We're going to talk about this in a sec. But up here we see exactly what's going on. When you launch the executable, you specify a target, whatever the type of box it is. So we have to go through this list and pick one or ones that match what we're trying to do. We need to specify the IP. We need to specify a port, but that's optional. We've already got a port set up, so we're going to, or we already got the default port, I should say, set up for this. Its default is 443. Seeing this is optional, we probably don't need to specify a port, but we have this number of connections to try, and it recommends a range of 40 to 50. If you don't know, we don't know, so we're going to try 40. All right? So that's what we're going to do. We're going to say .ssl, specify a target, specify our IP address, and then give us 40 connections to try. Okay? Now, when we go through this, we have to find the box type, the supported box, we're going to call it, that matches our environment. And when we get down to the red hats, we start seeing a little bit better of what we might have. We have Red Hat Apache 1320. All right, it's 1320-16, but it's Red Hat Linux Apache 1320. So that's the one I would focus my attack on. I don't see another Red Hat with 1320 as the type of Linux. So I'm just going to focus on this one here. This Red Hat Linux 7.2 Apache 1320. I've got both of these, 0x6A and 0x6B. And of course I would try both of them. I will tell you right now, 0x6A kind of works but doesn't really work. 0x6B will give us much better results. So that's the one we're going to try. Alrighty? If there are any other ones that match my Apache environment, I would try them as well. Again, you want to try all of them if you're trying to write a report on vulnerabilities. Alright? So, 6A and 6B, we're going to focus on 6B. And we're going to make that our attack. So it's going to be ./SSL 0x6B. My IP address, 192.168.56.134. And as I said, -C 40. Make sure that I'm typing this in properly. Yeah, it doesn't have any switches for the target or the IP. It just has a switch identifier for the number of connections. Alright? Which kind of makes sense. So 0x6b 192.168.56.134 and try 40 connections, and let's see what we get. First off, it's running. That's a good sign. It's trying to make a connection. It has spawned a shellcode. Awesome! First thing we always do. Who am I? Brilliant. Oh, I'm just Apache. Blast and damnations. I want to be root. Did everybody see that? Okay, we're not quite done yet because we want to be root. We want to do some privilege escalation here, and there's a couple of ways you can do it. But we need to pay attention to something here. When we ran this, it threw an error. This error here, trying to connect to packetstormsecurity.net, host not found. It tried to compile something called ptrace-kmod, which it was trying to download. It wasn't able to find it. It wasn't able to download it, and it obviously didn't make it. So it looks like it's trying to compile and create something called exploit. If I do an ls, of course there's nothing in that directory, but well, let's do a pwd as well and see where we are. Okay, and we're going to come back to that at the very end of this. Alright? So it's trying to grab something called ptrace-kmod.c from this packetstormsecurity.net server. Now it's possible that that server is offline, but that's not what the issue is. As we saw before, and I really should be following my notes to make sure I'm not missing anything, but I like doing these off the seat of my pants here. So, as I said before, and as I say time and time again, you must understand your environment. That's the only rule I have. Everything else is you have to do whatever you have to do, but you must understand your environment. This is the machine we are targeting. We are targeting it from Kali. We launched our attack over our host-only network, and we now have a shell running on the K1 server. That K1 server, we then told it to go to the internet and grab that ptrace exploit file. K1 does not have access to the internet. It has access to the host-only network only, and there is no gatewaying and routing that allows it to go through the host-only network, through the host environment, out to the internet. That would be a bridge adapter. And I set this up to avoid that. When we set these attacks up, we run them internally, and we run them on a segment where these target machines don't see the internet. It's not quite so important when it comes to doing pen testing. It is critically important when it comes to doing a malware analysis. You don't want your target machines accessing the internet. Okay? So it's a general overall good process to get in when you get into this side of information security. The technical, the hands-on stuff. Segmenting and isolating your machines is a good thing, in my opinion. So I need to get this in place, or I need to compile it, or something. The problem is that I really don't have a way to get this on the internet other than adding another adapter, which I can't do because I don't have access to this machine yet. So I have to trick this machine to go to my Kali machine and grab the file and download it. So as the notes say, I need to do 3 things to make this happen. I need to modify the compiled code to look at Kali. I need to download that source file into a directory where it can download it, and I have to set up a web server on Kali so that it has a document root so it can grab that file. And all of these things are surprisingly easy to do in Kali. All right? So what should we do first? Well, first I need to exit out of this shell here, because even though I'm connected, I'm not connected well yet, and I really want to address this ptrace error that I have here, which kind of makes sense right here. It says, if required, host ptrace and replace wget target. So it's telling us what to do right here. All right. So the first thing I'm going to do is I'm going to grab this file. All right. I'm actually going to do, well, let's find it first so we can understand it. So I'm going to use nano. You don't have to use nano to open up this compiled file. We took a look at 47080.c, and now we're going to modify it. You can use nano to modify it, or you can use the built-in text editor. It's called Mousepad. You can use Mousepad to open up 7808.c, and then that gives you the, I think it's almost 1,000 lines file. I don't care. You do whatever text editor you want. You want to impress people in the future, figure out how to, and start using Vi. All right? There is a search feature. I'm going to look for ptrace. All right? That's the first instance. Where's the next one? And when I come down, I find another instance which, hey, kind of makes sense. There's a wget command. It's going to this packet storm security, and it's looking for the ptrace kmod.c. Once it's downloaded it, it compiles it, and then it uses some arguments that removes the source code, and then it runs the exploit. So this makes sense, all right? It goes to the temp directory, and we're going to come back to that in a bit. It downloads the source file, compiles the source file with arguments, and then removes the source, and then runs the exploit. Part of hacking is, as always, removing evidence of your presence, okay? So that's what it's trying to do. Unfortunately, when this is pushed to the K1 server, it does not have access to this. So we need to modify that. We need to tell it to not go to this site, but what we need to tell it to do is to go to our site. For me, that is, as I said before, 192.168.56.198. So I'm going to change all of that structure to 192.168.56.198. And of course, I'm just running a regular web server, not an SSL server, or I will be shortly. Okay? So this is why we make a local copy. because sometimes we need to go in and modify the source code for our environment. I'm telling this exploit, this open fbang exploit, to not go to the internet, but go to my Kali machine, and I will put this in the document root of this website that I know K1 should have access to. All right. So first off, as I save this, file save, perfect. So it's been modified. I can close or minimize that now. Same thing with Nano. All right. If you're going to do it in Nano, oh, actually no, I'm going to close that first off. I'm going to close that down. And as I said, I could just as easily do it in Nano. No, I'm not doing it in that window. Let's go over here. Nano 47080. There's a control W for where is. I can look for ptrace again. Control W to find it again. It's already got ptrace in its buffer, if you will. And it takes me down to that line. And I could just as easily modify it in Nano. Control O to write out. No. Control O to write out, and then Control X to exit. Okay? That was step 1. Step 2 is to actually grab that file and put it somewhere. Now I have a work folder here called K1 that seems like a perfect place for me. Question? Yeah. Step 1? Yeah. Do you want to use the graphical tool, or do you want to use the text editor? The command line? Okay. Did you do it in mousepad? Then you're caught up, because you can do either or. You don't have to do both, sir. Okay, I didn't make that clear. That's on me. I apologize. Either or. You don't have to do both. All right? If you prefer the command line, you can even do Vi if you want. But don't do Vi in these classes. If you want to learn Vi, there's lots of resources online. Vi is a great tool. I prefer Vi. It's very easy to find stuff. It's very easy to delete stuff and replace stuff. I love Vi. But use mousepad if you prefer a graphical notepad-like interface with syntactical highlighting. Alrighty? So we've changed our source code. We need to grab this file. So we're going to wget this file here. I'm just going to highlight it, middle click to paste it, and it should grab that file. The reason why I can do this is because I'm doing this in Kali, and I can grab this file no problem. All right, I got a 200 code, which means it was successful. It downloaded almost 4K of data. This makes sense. So now I've modified my source code, told it where to look, step 1. I've downloaded the file into a directory, step 2. The third step is to actually launch a web server to serve this up. There is a module in Python that is perfect for this. There's actually a few of these modules in Python that will very quickly give you server functionality simply by invoking one of these modules. The one we are going to use is called Simple HTTP Server. All right. So we type in Python, and it's going to be a command, but we're loading a module. So we tell it to load the module, and the module is simple H, and tab is your friend. Simple HTTP server. It is case sensitive, so match the case and use the tab key. It is a lot easier. By default, it uses port 8000. Now, when I modified the code, I didn't tell it to use port 8000. I could have, but rather than that, I know that there is no web server running on Kali by design. So I'm going to tell it to do it on the standard port 80. So I have to specify a port. All right, and I have to do it as root. If there was an error, if there was a problem, if that port was already in place, it would throw a different error. It would say port in use, but you need to do it as sudo. All right, any questions on that? Okay. So I've modified my source code, I've downloaded the file, and I have set up a simple web server. We can test this very easily. When I go to localhost, there is my ptrace-kmod.c file. So I know my file is in place. It should be accessible by that exploit. As I have changed the source code, I need to recompile my file. We do that with the same command as before, gcc-o ssl 47. I need to be in the correct directory, of course, and gcc-o ssl 47. This is another reason why tab is your friend, is that it helps you catch when you make mistakes like that. Okay, so I think it's -l crypto, isn't it? -l crypto, perfect. Okay, so I'm going to recompile it with the new wget arguments. Again, it looks like it's working. ls-al perfect ./ssl, and let's see what happens. Oh, that's right, I need to specify arguments ./ssl 0x6b IP address, and then we're going to try 40 concurrent connections. So this time we don't have errors. This time it grabbed the file, it looks like it uploaded it, it looks like it ran the GCC command, and then it's looking for an SUID shell, which is promising, because at this point we are now logged in as root. Okay, any questions on that? All right, so that's basically it from me. I'd like you to try and do this on your own. Friday's class, I guess that's tomorrow. Friday's class is for you to finish the K1 activities. There is no competency, but go through and be very comfortable with these tools, including getting the enum for Linux working through the legacy version of Kali, just by simply booting and running a live DVD rather than installing version 16, for example. Okay? Any questions? One last thing I want to draw your attention to. Last time we ran this exploit and I was able to get in. I was able to get in. Where the hell is it? Must be on this one. I must have scrolled past it. I was able to get in as Apache. Alright? And so when I look at my attack here, I'm still connecting as Apache. I am downloading and compiling and creating a new file, and then running that new file, and then elevating my privileges or escalating my privileges to root. Okay? There was a two-step process there, but first I connected as Apache and I downloaded a file, saved it locally, and then I compiled the file and saved it locally. Normally you can't do that as Apache. Normally systems block server IDs like Apache, like the SSL server ID, or whatever. Any of these processes that run web-facing servers have an ID that has very limited read-write access outside of their directory structure by design. Okay? The one exception to that is the temp directory. Pretty much everybody has access to the temp directory. Because everybody has access to temp directory, if you are somehow able to get a shell into a system, we're talking Unix systems obviously, but you want to try privilege escalation, you want to download something and compile it and see if you can elevate your permissions, the place to do it is in the temp directory, because that's the one place where you probably have permissions to do things like create files and compile stuff because based on the modifications you make to those files. All right? Any questions on that? I'm going to stop recording.